Well, let's go ahead and start. The first section is rectangular coordinate system and graphing utilities. And the first topic is plotting points on a rectangular coordinate system. And I'll skip around a little bit on this. But this is our x-axis, this line going across here, the horizontal line. This line going up and down is our y-axis, your vertical line. Usually they're just labeled with x's and y's. Where they intersect has a special name. It's called the origin. Now, if we look at something called the quadrants, sometimes you'll have problems refer to which quadrant it falls in. This is our first quadrant. This is our second quadrant. This is our third quadrant. And this is our fourth quadrant. So it doesn't go quite maybe in the direction you might think. Let me go ahead and clear those off. Now if I were to look at the x-axis a little closer, these tick marks here represent some kind of distance. Maybe this is 1, 2, 3, 4. As you go further to the right, it increases. And this is -1, -2, -3, and -4. As it goes further to the left, it decreases. Now, you don't have to go by ones. You can go by tens or hundreds or whatever is appropriate for your problem. As we go up, this would increase. 1, 2, 3, 4. And as we go down, it would decrease. That's -1, -2, -3, and -4. Now we're going to be taking a look at plotting points. Now a point is similar to this example. You have parentheses around it, comma in between two numbers. Now these numbers represent our x part and our y part. So that's our x, and this is our y. So I go to where x is equal to 2. Remember, this is your x-axis and this is your y-axis. So where x is equal to 2, and if I were to draw a vertical line, it'd more or less look like that. Now if I go to where y is equal to 3, and I draw a horizontal line, it'll more or less look like that. And where they intersect would be our point. Now oftentimes these have letters in front of them that might have letter A. And you do that so then you can come over here and just simply put an A on your graph to indicate what that point is. So that's how you plot a point. If it's down here on one of the axes, this right here would be the point. Our x value is 4, but our y value is 0. Because if I were to come straight over the y-axis, that's y is equal to 0 there. If I had a point right here, this would be 0, -3. Same reasoning for the x value. If I were to go straight up to the x-axis, that's x equals 0. And then it crosses at -3. Now this point in the middle, we said is the origin. That'd be the point 0, 0. It's kind of, if you've ever played that game Battleship, where you put pegs down and you look at where they intersect. They say A5. And so you look at the A and 5, and then that's where you put the peg. Same idea as this. Now that's the first topic, plotting points. Our next topic, I'm going to skip around a little bit, says graph equations by plotting points. That kind of goes hand in hand with plotting points. If I have y is equal to 3x minus 1, and I want to graph this by plotting points, we create something called a t-chart. And the t comes from this right here. These will be our x values and these will be our y values. And you pick anything for x. You want to keep them fairly small. And say -1, 0, and 1. I'm getting ready to sneeze. Oh, excuse me. Probably should have muted myself, but I'd have to figure that out. I'd have muted real fast. Okay, so then we're going to plug that in to y is equal to 3x minus 1. Everywhere we had an x, we'll put in parentheses. And this particular problem, we said x is negative 1, so put negative 1 inside those parentheses. 3 times negative 1 is negative 3, minus 1 is negative 4. So that point is going to be negative 1, negative 4. My next x value is 0. And again, we'll go through y is equal to 3x minus 1, and we'll replace our x with parentheses. Everything else remains exactly the same. But here we said x is equal to 0, so I put 0 in for the x. 3 times 0 is 0, minus 1 is negative 1. 0 is almost always a perfect choice because it causes things to drop away. And then I plug in x equals 1. So I'm going to have y is equal to 3 and times x, so I put parentheses where the x was, minus 1. And this time we said x is equal to 1, so I put a 1 in here. 3 times 1 is 3, minus 1 is 2. So after we get the appropriate number of points, we'll go ahead and plot them. Negative 1, negative 4 would be more or less right here. 0, negative 1 would be right here. And 1, 2 would be right here. And then I'll draw a line through them, and that'd be your graph. Now the problem with plotting points in order to figure out what the graph looks like is you almost have to know what the graph looks like before you begin. I knew that I was dealing with a line because everything's the first power, which means I knew 3 points would be good enough. 2 points is actually all you do need, but the third one's kind of a check on your math. But if I had something that looked like this, y is equal to x to the fourth minus x to the third plus 1, how many points do you need? What's it supposed to generally look like? We don't know that. And we'll take a look at graphing equations using graphing utility to help us with that. So let me clear this off. And now we're going to go back and cover the distance and midpoint formulas. That's our second topic here. So, given 2 points, x1, y1, and x2, y2, then we're going to have the distance. And distance formula says d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. We'll also have our midpoint formula. And midpoint is going to equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So let's pick a set of points, negative 3, negative 1, negative 4, and I don't know, 5, I guess. And let's find the distance between those 2 points, and we'll also find a midpoint that lies between these two. Well, first off, I need to label these. This is my first point, so this will be x1, y1. This is my second point, so this will be x2, y2. Actually, it doesn't matter which one you label as your first point, which one you label as your second point. It works out either way. Now I'm going to go to my distance formula, and I'm going to go through and replace all my variables with sets of parentheses. And the parentheses that's already there, I'm making them a little bit bigger. These parentheses are necessary if you mess up on signs. If you don't mess up on signs, it's not as critical. Okay, so all I did is it looks exactly like this. I just replaced the variables with sets of parentheses. Now y2 is 5. y1 is negative 1, x2 is negative 4, and x1 is negative 3. So then we're going to have a negative negative becomes positive, so this is 5 plus 1 squared plus negative negative here becomes positive, so we're going to have negative 4 plus 3 squared. 5 plus 1 is 6, so we got 6 squared plus negative 4 plus 3 is negative 1 squared. 6 squared is 36, negative 1 squared is 1, so our distance is going to equal a square root of 37. Now, if the square root could be simplified at that point, we would. Or if the instructions said to round to 2 decimal places, we'd plug it in our calculator. Now for our midpoint. Now, probably no need to put any extra parentheses in this. It's a simpler formula than distance. It says we're going to add together the x parts. So I got negative 3 and negative 4, and then divide by 2. And we'll add together the y parts and divide by 2. So I got negative 1 plus 5 divided by 2. So then negative 3, negative 4 is negative 7, so we got negative 7 halves. Negative 1 plus 5 is 4, so we got 4 halves. And that gives us negative 7 halves, and 4 divided by 2 is 2. And that would be our answer. Let me grab a drink here. I'm going to clear this off. Let me just go back here briefly. I just wanted to point out that here's where the recorded sessions are. So if you want to review any previous ones, that's where you'll find them. I record this, but I don't know if I ever showed where those located at. Now we're going to identify x and y intercepts. Now I'm going to do this algebraically because down here in section 2.3 it says determine the x and y intercepts. But this implies looking at your graph. Well, looking at your graph is pretty easy. You just look to see where it crosses the x and y axis. So since we're talking about the x and y intercepts, let's talk about how to find them. Okay, so the x-intercept is where the graph crosses or touches the x-axis. And the y-intercept is where the graph crosses or touches the y-axis. Although I'll focus on the linear, if you had something that had a higher power like quadratic, it might cross in 2 places for the x-intercept. So you might have multiple locations. Now to find the x-intercept, step 1 is you plug 0 in for y, and then step 2 is you solve. Now finding the y-intercept. Step 1, plug 0 in for x, and step 2 is solve. It's always the same. To find the intercept, you always plug 0 in for the other variable, and then you solve. So let's take a look. Let's say I had 3x minus 4y is equal to 12. And I want to find the x-intercept. Well, you plug 0 in for the other variable, so we'll plug 0 in for y. So we got 3x minus 4 times 0 is equal to 12. And then step 2 is to solve. Well, 4 times 0 is 0, so it drops away. We got 3x is equal to 12. Divide both sides by 3. And we end up with x is equal to 4. If you want to write that in point form, that'd be 4, 0. Now for our y-intercept. You always plug 0 in for the other variable, so I'll plug 0 in for x. So I got 3 times 0 minus 4y is equal to 12. And then step 2 is solve. Well, 3 times 0 is 0, so it drops away. Then we got negative 4y is equal to 12. Divide both sides by negative 4. And we end up with y is equal to negative 3. Or if you write in point form, that'd be 0, negative 3. Now if I had something of this form, y is equal to x squared minus 7x plus 6, and we were to find the x-intercept. You plug 0 in for the other variable, so plug 0 in for y. So we got 0 is equal to x squared minus 7x plus 6. Now to solve this one, we'd have to factor it. This factor is using the PST method. Factors as x minus 1 times x minus 6. And then we'd use a zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 1 equal to 0, and I'll set x minus 6 equal to 0. And that gives us x equals 1 and x equals 6. And if you want to write them in point form, that'd be 1, 0 and 6, 0. Now for our y-intercept, you always plug 0 in for the other variable, so we'll plug 0 in for x. We'd have y is equal to 0 squared minus 7 times 0 plus 6. 0 squared 0, negative 7 times 0 is 0, so we get y is equal to 6, or in point form would be 0, 6. Now that's our intercepts. Now graphing equations using graphing utility, and we'll focus on the TI3, TI4, and I won't show you all the different pieces. You can watch a YouTube video and see that, but I'll show you some of them. Let me clear this off. And if I'm not writing buttons down, you might actually might have time to show them all. All the ones you'd particularly need for this class, that is. And as soon as it loads, there it goes. Now we're going to look at all the different basic graphs that everything's comprised of. We'll first start with y is equal to x. We'll look at y is equal to x squared. Y is equal to x to the third. Y is equal to x to 1/2. Y is equal to square root of x. Y is equal to cube root of x. Y is equal to the fourth root of x. And y is equal to the absolute value of x. Okay, so y is equal to x. On my calculator, if I press y equals, you'll get to a screen that looks similar to this. And if you press clear, it clears out whatever's on that line. And I have a 0 on y2, so I'm going to go down and clear that off. I just down arrowed go to y2, so now I'm going to go up arrow back to y1. Okay, so you do y equals clear, and now I'm going to simply push this x key right here. You see it in red what I've selected, and then graph. And then that'd be your graph. Now, if you have a TA3, TA4 and it doesn't look like that, then we're going to take a look at fixing graph mode on a TI-83, 84. And our first thing we'll do is we'll unhighlight plot 1, plot 2, and plot 3. Second thing we do is clear out Y1 through Y0. And third thing we do is we push our zoom button and then choose Z standard. Okay, unhighlight plot 1, plot 2, and plot 3. If I press Y equals to go back here, you see across top says plot 1, plot 2, and plot 3. Those shouldn't be highlighted. If those are highlighted, then what you're going to see, I'm going to up arrow, put my flashing cursor on plot 1 and push enter. What you'll see is one of 3 things will happen if I push graph. One thing will happen is it'll come up with an error. It'll say invalid dim. And if yours says that, you just press enter on the quit. And then we'll talk about how to fix it. One thing that will happen is it'll work just like normal. And a third thing will happen is it'll have extra garbage on the screen like what you've seen on my display. See those extra little boxes there? Well, to fix it is easy enough. If you go back to Y equals, if you see any of those highlighted, you up arrow, put your flashing cursor on whichever one's highlighted. You may have to right arrow over to that, and then press enter one time. Now if you do a down arrow, you'll see the highlighting off of it. And if you press graph, it'll fix whatever error that occurred. Second item is clear out Y1 through Y0. If you go back to Y equals, you can freely go back and forth between the Y equals in the graph. Then if you scroll down, so you got Y7, Y8, Y9, it goes down to Y0. If you have garbage down here, sometimes students will get like closing parentheses down here. They'll push their buttons by accident, get some garbage down here. And if you exit out, they go back to Y equals, they don't see it. And they don't realize there's an error down there. So if they press graph, then they'll get a syntax error. Whenever you get syntax error, you should always choose go to. So how you can choose it is you can down arrow to it and press enter. Enter's down here. Or you can simply, once you get into this, press your 2, and that'll do the down arrow and do the enter for you. Now it'll go where the error is, and once you see that, then you can press clear to clear that out. Now the last item to fix your graphing calculator. You press zoom and choose Z standard. So zoom is right here. Z standard there are 6 ones. You can down arrow to that line and press enter, or simply press the 6. Now set your zooming window back to -10 to +10 on your X and Y axis. Okay. Let's go on to our next one. Y is equal to X squared. I'll press my Y equals, press my clear. I do my X key, which is right here, and I push my X squared, which is right here. And I didn't mean to push that twice. Let me use my arrow key and press delete to clean that second one off. And then push graph. That's curious. It almost acted like the 2 squareds was okay to have there. Let me just out of curiosity. I don't even know what that indicate. X squared squared, X to the 4th? Maybe. Interesting. Anyway, it should only be 1 squared there. Now, this next one, X to the 3rd, I could care less what X to the 3rd looks like. What I'm demonstrating is how do you have it when you have some kind of power. The 4th power, the 5th power. So if I do X caret is how we do the exponent. And then 3, then that's what it'll look like. Now, if you have one of the newer TI-84s, it doesn't actually put this caret on here. It puts up a little exponent. So when you put 3 up in there, it looks like it's in the exponent. If you have one of those calculators, the trick to it is press your right arrow key to get out of the exponent. And then you press graph. and that'd be our y is equal to x to the third. Now, next one we're going to look at is y is equal to x to 1/2. And I could care less what this graph looks like. What I'm demonstrating is how do you handle when you got any fraction up in the exponent. Even more than that, anytime you have more than a single number or a single variable up in the exponent, you handle this the same way. You got to put parentheses around it. So when we plug that in, we want to put parentheses around the 1/2. So I'll press my y equals, clear, then do my x key. We always do x power with the exponent with the caret. Then beginning parentheses, 1 divided by 2. And you can put a closing parentheses if you want to close that beginning one off. And then graph. And that would be our answer. Now, some of you have the near T84. You don't have to put the parentheses around the 1/2 because it's already all up there up in the exponent. And next one is the square root of x. Now I'm going to press my y equals, clear. The square root. Some things are above buttons. You see above the x squared it says square root. So if I do second x squared, that'll put a square root on my calculator. And I put my x in, and then I'll push graph. Closing parentheses at the very end are optional. That gives the same graph as y is equal to x to 1/2, which it should. They are the same graph. Now the cube root of x. I'll press my y equals. Let me actually clear that off. Y equals, clear. Now if you don't see whatever you're choosing on a button or above a button, it'll be underneath the math button for graphing purposes. So if I go into the math, you'll see the cube root is the fourth one. So you can down arrow to it and press enter on it, or simply press the 4. That's up to you. And then I'll put my x key in, and then I'll do a graph. Those of you at the near T84, to get it out of the, it puts actually a radical symbol on there. To get it out of the radical, you have to use your right arrow key. Right arrow key is the key to all of those. And that gives you your graph. Now the fourth root of x. I don't care what the fourth root of x looks like. What I'm demonstrating here is how do you handle it when you have any index. So if I press my y equals, clear, I put my index in first. So I'll put a 4 in there. Then I'll go to math. And we want to choose the fifth one. The one is the radical with an x there. Now I'm going to put my beginning parentheses. Then I'll put an x in. And you can put a closing parentheses if you want. That's optional at the very end. And then graph. One more. Absolute value of x. Well, if I go to y equals, clear. And it's not on a button, it's not above a button, so we know where it'll be. It'll be underneath the math button. Push my math button. Now it's not in our first menu here. So if I right arrow to the num menu, you see ABS is the first item and it's already highlighted. So we simply press enter on it. Put your X key in, and then graph. And that would be our absolute value of X. Now to exit out of anything in your calculator, you do second mode to exit out. Now, instead of graphing equations using that way, you could plot points. You'll find that it'll be much faster if you do have a TA3, TA4. Our second section we'll take a look at is circles. And let's talk about the different forms of a circle. They refer to a standard form and a general form. So if we have something of this form, x minus h squared plus y minus k squared is equal to r squared. This is standard form. H, K, and R are numbers. Our circle would be HK. And our radius would be R. Now, this first problem says write an equation of a circle in standard form. Although that could mean different items. Let's say they give us the a center. What did I write? Circle there? Let's try that again. Center. Okay, so let's say they give us the center. 3, -1. And they give us a radius of 2. And so to write to standard form, we got x minus h squared plus y minus k squared is equal to r squared. We have to identify our h, k, and r. Well, if they give us a center, they're giving us h, and they're giving us k. If they're giving us a radius, they're giving us r. So then, we got our x minus h squared plus y minus k squared is equal to r squared. We just plug in what we identified. So x minus h is 3, plus y minus k, and k is -1, is equal to r squared, so that's 2 squared. And you do a little bit of simplifying. So that's x minus 3 squared plus negative becomes positive. So that's y plus 1 squared, and 2 squared gives us 4. And that would be our standard form. Grab a drink here. Now the second item talks about writing a general form of an equation of a circle. And I guess I could continue with this problem. General form means get rid of the parentheses to begin with, and then we'll get it in a certain form. Let's start off getting rid of the parentheses. X minus 3 times x minus 3. That's what x minus 3 squared means. And y plus 1 times y plus 1. Now if I FOIL this, x times x is x squared. X times -3 is -3x. -3 times x is -3x. -3 times -3 is 9. Plus y times y is y squared. Y times 1 is 1y, or y. 1 times y is 1y, or y. And 1 times 1 is 1, equals 4. Now I'll combine together like terms. -3x, -3x is -6x. And I got y squared. 1y plus 1y is 2y. 9 plus 1 is 10. And then I'll bring that 4 over. And it becomes a -4. Now we're going to have x squared. And then we'll put the y squared right next to it. So the squareds go first. And then minus 6x plus 2y. So the x the first power and the y the first power come next. 10 minus 4 is 6, equals 0. Now there's different variations of what does general form look like. So you have to read the instructions to see exactly what they're talking about. What I've seen in some books is they'll indicate that you cannot have fractions in a general form. So if I had a 1/2 before the x squared and y squared, I'd want to multiply everything by 2. In other cases, I've seen where they are perfectly happy with having a fraction in there. Now that's very rare when you see that. I've seen some books that indicate you cannot have any numbers in front of the x squared and y squared, which means usually you have to have fractions in some of the problems. So, like I say, you just have to read it and see exactly what it's referring to. But what is the convention in every book I've seen is the squared parts go first, the first powers come next, and then the number is either here or on the right side. Okay. Let's take a look at section 2.3. This talks about functions and relations. It says determine whether a relation is a function, and goes through some different items here. Let's talk about what a function is. Function says for every x, there is only one y, and let me take a quick break here. And there we go. Sorry about that. Now, that's a hard definition to work with. It only really works well with points. So we got an easier definition. It says if you have one of the following, it is not a function. If you have y to an even power, it's not a function. If you have the absolute value of y, it's not a function. If you got the plus or minus symbol, it's not a function. Or if you got x is equal to a number, such as x is equal to 3, that's not a function. Now, these are the most popular ones you run across in books. It's definitely not all-inclusive of all the ones you might be able to run across. And what didn't I like about absolute value? Oh, it's not capitalized. So how you'd use this, let me clear this off. They're yes or no questions. If I had y is equal to 3x minus 1. Well, we don't have y to an even power. We don't have an absolute value of y. We don't have a plus or minus symbol. And we don't have x is equal to a number, like x is equal to 3. Now, if we had x equals a number, that's all you would have, is x is equal to that number. You would not have any x squareds, you wouldn't have any y's, and so forth. So this one, the answer would be yes, it is a function. Now, on the other hand, if I had x squared plus y squared is equal to 4. Now, this is a circle, but notice how we have y to an even power? That y to an even power would tell us that no, this is not a function. Now that's determine whether a relation is a function. Now it says apply function notation, so let's talk about that topic next. Function notation has two purposes. Its first purpose is to give a name. You might be sitting there and look at that, it's like, well, what in the world does that mean? Give a name. If I had y is equal to 3x minus 1, and I had y is equal to 5x plus 2, and I told you to graph y, well, your question would be, well, which one? There's two y's. So instead of calling it y, I give it a name. So I call this one by this name. Now, we don't give it names like Bill and Bob or anything. Now, how you read that, that's read as f of x. Or we even get lazier in math, and we just simply say f. Now, this one, I may give this name to. And you read that as g of x, or simply g. Now, there's no mathematical meaning here. It doesn't mean f times x, doesn't mean g times x. That's purely just a name. Now, the letters actually mean something when you get in application problems, like you might use p of x for profit, little p of x for price, c of x for cost, r of x for revenue. So you change them to match. But for the most part in algebra, we just deal a lot with f and g, just generic names. Now, if I told you to graph f of x, or I told you to graph g of x, you'd know which one I was talking about. Now, these are interchangeable. You could, if you have a y there, you could put a function notation. You could put f of x. If you have f of x, you could replace that with y. So that's entirely up to you. Some people like when they're graphing to have it say y equals, but it doesn't matter. Second purpose is to reduce writing. And we'll see what in the world I mean by that with an example. Had problems before that would say evaluate y is equal to 3x minus 1 for y when x is equal to 5. And what you would do is you go through, and everywhere you have an x, you'd put in parentheses, and then you put 5 in. So you'd have y is equal to 3 times 5 minus 1. 3 times 5 is 15, minus 1 is 14. Well, instead of doing all that writing, what you could simply say is f of x is equal to 3x minus 1, and say find f of 5. Now this notation, this wording here, says the exact same thing as the previous example. And we solve it the same way. To find f of 5, you go through and put parentheses where your x was, and then you'll put 5 in. And 15 minus 1 is 14. So those are the two purposes of function notations. And we applied function notation. We already found the x and y intercept, so we won't show that again. The domain and range. Let's talk about that. Now your domain is your x values where your graph exists. Your range is your y values where the graph exists. Now in general, for the domain, your domain is all real numbers except ones that cause a denominator to equal 0, and ones that cause a negative inside of a radical with an even index. Now when we get to logs later on in the course, you'll find that there's an additional one we put on there. Now finding the domain of a fraction, specifically where we have variables in the denominator. Step 1. Set the denominator, bottom part, equal to 0. Step 2 is to solve. And step 3 is to put a slash through the equals. So if I had f of x is equal to 7 over, let's see, let's say 7x plus 10, that'll factor. Then the instructions were to find a domain. Step 1, set your denominator equal to 0. So I got x squared minus 7x plus 10 equal to 0. Step 2 is to factor. Well, we'd factor using the PSD. And factors is x minus 2 times x minus 5. Now our zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0 and x minus 5 equal to 0. And I get x equals 2 and x equals 5. Now these are the values that it cannot be. So we had to put a slash to the equals. So x cannot equal to 2 and x cannot equal to 5. There's different ways you can write that. That's one method. Another method is interval notation. And that's where you start with negative infinity, parentheses on negative infinity, comma, you go to your smallest number, which is 2, close parentheses, union, beginning parentheses, smallest number, comma, largest number, and then union, and then largest number to positive infinity. Everything has a parentheses on it. This says the exact same thing. The x cannot equal 2 and x cannot equal to 5. Now, if we want to find finding the domain of a radical with an even index. Step 1. Set what is under the radical, radicand, greater than or equal to 0. And step 2 is to solve. Let me clear this off. So we got f of x is equal to the square root of 3x plus 7. Let's say the instructions are to find a domain. Well, step 1 is you take what's underneath your radical, 3x plus 7, and set it greater than or equal to 0. And then step 2 is to solve. So I'll take the 7 over, it becomes a negative 7, and divide both sides by 3. And you get x is greater than or equal to negative 7/3. Now you could write it that way, or if you want to put it into interval notation, you could have a bracket. Bracket means it includes it. Bracket on negative 7/3, comma, and it's going to positive infinity, because it's a greater than. Now that was identifying the domain algebraically. Now they refer to that, I think, down below. If they were giving you just a graph, I guess they weren't referring down below. I thought they were. No. If they're just giving you a graph, and that's what this last one kind of implies too, is you would look at the graph and see where the graph exists for the domain and range. By the way, there's no algebraic way to determine the range. No easy one anyway. Usually you look at the graph and that tells you. Let's say I had this this example right here. And I wanted to know the domain and range. D for domain and R for range. Domain is your x values, where your graph exists. Now, here's where my graph begins. It doesn't exist over here. So if I were to go straight down to my x-axis, that's x equals 0. The only time we put a parentheses is when it's infinity or there's an open dot, open circle. And then it's going forever to the right, so it's going to positive infinity. Now our range. If I come down here, our graph doesn't exist down here at all. The lowest point is right here, which is directly on y is equal to 2. And as this is going to the right, it's slowly going up. It'll keep slowly going up forever, which means it's going up to infinity. And that would be our domain and our range. Okay. Let's look at section 2.4. And this gets into linear equations in two variables. And it talks about graphing linear equations in two variables. Well, we have looked at a couple examples already. One where we plotted points, and one where we plotted points and graphed it. Another one where we plugged in our calculator. So we're not going to show another one. We're going down the slope of a line. I'm going to kind of jump around here, just because I don't got time to cover everything, and I want to hit the more important topics. So the slope. Now, our slope is represented by the change in y over the change in x. Now this apply the slope-intercept formula and compute average rate of change. Well, this is where you can replace x and y with anything. Miles per gallon. Change in miles over change in gallons. Change in profit over change in time. So you can put anything in here to find the average rate of change. Now given 2 points, x1, y1, x2, y2, then our slope is going to be y2 minus y1 over x2 minus x1. For example, if I had, let's see, 3, 1, and negative 5, 7. Given 2 points, this is my first point, so this will be x1, y1. This is my second point, so this will be x2, y2. We're going to plug them into our formula for the slope, if that's our instructions. And I'll go through and replace all my variables with sets of parentheses. Now I'm going to plug in what I identified. y2 we said was 7, y1 is 1, x2 is negative 5, and x1 is 3. So then 7 minus 1 is 6, negative 5, negative 3 is negative 8. And you always simplify, so I reduce this to negative 3/4. And that would be your answer. Now the next part talks about the slope-intercept form, and this goes hand in hand. This kind of all goes together here that we're going to take a look at. Let me erase this. So our slope-intercept form is y is equal to mx plus b. Y is by itself. Now it could be y, or you could put f of x there. And then we got m times x plus b. M and b are numbers. M is our slope, and b is our y-intercept. Now, even if they don't say to put it in this form, you should always put things in slope-intercept form. It serves a couple of different purposes by having it in that form. One is you can put it into calculators easily. Anytime you have it solved for y, you can put it into the TA3, TA4. Another purpose is it allows you to easily identify the slope and y-intercept. And then the last one is if you're doing it by hand, it makes graphing it a lot easier. We won't look at it in this video, but it does make it easier. We're going to take a look at finding the equation of the line. Now our first step is to find m. Second step is to plug in the given point for x and y, and m from step 1 into y equals mx plus b, and solve for b. And then step 3 is to write our answer. We're going to plug in m from step 1 and b from step 2 into y equals mx plus b. Let me clear this off. Let's say that they tell us the slope is 3. And it passes through the point 1, negative 2. And the instructions say find the equation of the line. Now step 1 is going to be to find m. That's easy. M's given here. So M's 3. Now step 2. Plug in a given point for x and y. Now when they give us a point, they're giving us a specific instance of x and y that we can use. Which means I'll plug -2 in for y and 1 in for x in this problem. And m we said was 3, so I'll plug that in also. Plus b. And then solve for b. Well, 3 times 1 is 3, plus b. Take 3 over the left side and get -2 minus 3 is equal to b, or b is equal to -5. And then step 3 says to write your answer. We're going to plug in m from step 1, which is 3. And we're going to plug in b from step 2, which is -5. So our answer will be y is equal to 3x minus 5. Now let's say on the other hand, they tell us it passes through 2 points. 1, 5, and -2 and 6. Same instructions. Well, this time, step 1 says find m. We have to use our slope formula. This is our first point, so this will be x1, y1. This is our second point, so that'll be x2, y2. And remember, our formula is m is equal to y2 minus y1 over x2 minus x1. So we're going to go through, and where our variables are, we'll put in parentheses. y2 we said was 6. y1 is 5. x2 is -2, and x1 is 1. 6 minus 5 is 1. -2 and -1 gives us -3. So m is going to equal to -1/3. Now step 2. It says plug in the given point. So plug in the given point. We're given 2 points. Which one do I use? Well, you choose whichever one you want, whichever one looks easier. I'm going to plug in the first one because there's no negatives. Numbers look a little smaller. So put 5 in for the y. M we just said was -1/3. And x is 1. Plus b. And then we want to solve for b. So we got 5 is equal to -1/3 times 1 is -1/3 plus b. And then I'll take -1/3 over, and it becomes a +1/3. Now this is a mixed number form. So we're going to take the number to the side, we'll multiply it times our denominator. 5 times 3 is 15, and we'll add a number up on top. 15 plus 1 is 16, and then our denominator stays as is. So b is equal to 16/3. Now we can't forget to actually write our answer. We're going to plug in m from step 1, which is -1/3. And we'll plug in b from step 2, which is 16/3. And that would be our answer. Y is equal to -1/3 x plus 16/3. Let me grab a drink here. Now sometimes they give you an intercept, or an x-intercept, or a y-intercept, or they give you the origin. Well, if they give you any of those, realize those are simply points. You just have to write them in point form, and then you can follow these same steps I gave you. Okay. So we applied the slope-intercept form, or I guess we came up with a slope-intercept form. Okay, it says apply, so use them basically. So I use both those. Now parallel and perpendicular lines. Let's talk about that. Now let me clear this off. So finding the equation of the line given a point and either a parallel or a perpendicular line? Step 1. Find M. Our first substep says to write the given line in slope-intercept form. Our second substep says to identify the slope. Our third substep, it says if there are parallel lines, if you're dealing with parallel lines, the slopes are the same. Now, if you're dealing with perpendicular lines, slopes are negative reciprocals. And we'll see what in the world this refers to. And then step 1 is to plug in the given point for x and y and m from step 1c into y equals mx plus b and solve for b. And then step 3 is to write your answer. Plug in m from step 1c and b from step 2 into y equals mx plus b. Okay. So let's say I had the point 1, 2, and is parallel to y is equal to 5x minus 2. Step 1. We want to find a slope, find m. Now, first thing we do is write the given line in slope-intercept form. Now, slope-intercept form means you got to solve for y. This is already solved for y. Our second substep says to identify our slope. Well, the reason why we put it in slope-intercept form is so we can easily see what our slope is. It's whatever number's in front of our x. Now C, parallel lines have the same slope. So we said that it's parallel to y equals 5x minus 2. We said the slope of y is equal to 5x minus 2 is 5. And since parallel lines have the same slope, then m is going to equal to 5. Now step 2 is plug in the given point for x and y. So plug this in for x, plug that in for y. So y is 2. M we just said was 5. X is 1 plus b. And then we want to solve for b. So actually 5 times 1 is 5. Then I take it over. That gives me a negative 5. And we get b is equal to negative 3. Now step 3 is write our answer down. Plug in m from step 1c, which we said was 5. And plug in b from step 2, which we said was negative 3. And our answer is y is equal to 5x minus 3. Now let's say I had point 2, 3. And it's perpendicular to, let me see, 6x minus 3y is equal to 2. Step 1. Find the slope, find m. Our first substep says to write the given line in slope-intercept form. Well, this one isn't in slope-intercept form. We have to solve for y. So I'm going to take the negative 3y, take it to the right side, take the 2 over the left side. So we're going to have 6x minus 2 is equal to 3y. And then we'll divide everything by 3. 6 divided by 3 is 2, so we got 2x minus 2/3 equals y. And that's in slope-intercept form. We got to solve for y. Now our second substep says to identify the slope. Well, slope is 2, whatever number's in front of your x. Now, perpendicular lines have slopes that are negative reciprocals. So what that means is we're going to start with slope from 1b. So start with a slope from 1b. Then we're going to write it in fraction form. So write it in fraction form. Now, if it isn't already a fraction, you can easily create a fraction by putting it over 1. Then we're going to flip it. Top goes to bottom, bottom goes to top. That's the reciprocal part. Reciprocal means fraction flipped. And then we're going to change the sign. So it goes from a positive 1/2 to a negative 1/2. That's the negative part. Now, some books refer to that as a opposite reciprocal. Some of them refer to it as a negative reciprocal. Okay, we're still passing through point 2, 3, so I'm going to carry that down. So we just found that m is equal to negative 1/2. It'll be whatever numbers here at the end after you get done going through that process. So then, step 2, plug in the given point for x and y. Remember, when they give you a point, they're giving you the specific instance of x and y you can use. So put 3 in for the y. M we just said was negative 1/2, and x is 2 plus b. And then solve for b. Those 2's cancel, and I got 3 is equal to negative 1 plus b. Take negative 1 over, becomes a positive 1. And you get b is equal to 4. Now step 3. Write your answer. Plug in m from step 1c, which we said was negative 1/2. And plug in b from step 2, which we just said was 4. And that would be our answer. Okay, so creating models using linear regression. Let's talk about that real quickly. So let me clear this off. Linear regression talks about coming up with a model, a line, that best goes through a set of points. May not be perfect, may have some error. For example, I'm gathering some real-life data. After the first year, let's say the profit was 5,000. After the second year, the profit was 7,200. After the third year, the profit was 8,300. And let me put one more. Fourth year, let's say it was 9,000. And I want to come up with some kind of model for me to predict what's going to happen in year 5 or year 6. Well, we're going to go put these into our calculator. So before I do that, though, I'm going to turn my diagnostics on. So you push your second button and push mode if you're in anything. So that exits you out. And then I'll do second 0 to go into the catalog. Now I want to push this x and negative 1 button because that will take me down to the d's. Or you can simply just down arrow over and over until you get to diagnostic on. Now once you get your cursor next to the diagnostic on, you simply press enter twice. Okay, so now your calculator is set up. You only have to do that one time. Now if I go to stat, do an enter on edit, and I want to up arrow and clear L1. Then we got 1 through 4, so 1, 2, 3, and 4. I'm going to right arrow over to L2. Maybe. There it goes. A little slow. And I'll put in my y values. So I got 5,000. I got 7,200. I got 8,300. And I got 9,000. Now after you get those input in, you exit out, so you do second mode. And I'll press clear to clear that off. And then we go into stat. We go to calc. And we want to choose our fourth one, linear regression. And then I'll press enter. And this will give us our model. Now you see it's given us an A and B. So up at the top, you got y is equal to ax plus b. That's this very right below linear regressions, right here. So they tell us A is 1310. So plug 1310 in for A. And then tell us B is 4100. Now this will be our linear model. This is done with linear regression. So I could use this to predict. For example, if I want to know what the value would be for at 6 years, I could plug 6 in for the x, and that would tell me what this would be. Okay, transformations of graphs. Let me grab another drink. I'd like to show this by example. First thing we have to look at, though, is our basic graphs. Y is equal to x is a line that looks like this. Y is equal to x squared is our U-shaped graph. This is beneficial to know what these graphs look like if you're plotting points, because that kind of generally gives you an idea of what they should look like. Y is equal to x to the third. Looks like this. That way, if you're plotting building a big T-chart, you know when to stop. Y is equal to square root of x. Looks like this. Y is equal to the cube root of x. Looks like that right there. And y is equal to the absolute value of x is our V-shaped graph. And it looks like that right there. Now for our transformations. If we have y is equal to x squared minus 2. If you got a number at the very end or very beginning, it shifts up or down. Since we got a minus 2 here, that means it's going to go down 2. Now what that means graphically is it's still going to look like this x squared, look like the U-shaped graph. We're just shifting the entire thing down 2 units. So it'd look like this. Now if I had y is equal to x squared plus 3. Again, your number at the very end or very beginning is up or down, so this plus 3 would tell us up 3. Means our graph still looks like the U-shaped graph, it's just been shifted up 3 units. So it would look like this right here. Now I'm going to really focus on the x squared, but these apply no matter what the functions are. So if I had y is equal to x minus 1 squared, if your number is inside with your x, it shifts left to right. Now here's a minus 1. It's always opposite what you think. The minus 1 makes us think left 1, so it's really right 1. Now it's still a U-shaped graph, just the entire thing has been shifted right 1 unit. So it'd look like that. And actually, let me pick one other example. I'll do an absolute value, just so you see how it works with the other ones. Now in this one, here are the numbers inside with the x, so it shifts left to right, opposite what you think. The plus 3 would make you think right 3, so it's really going left 3. Now it still looks like our V-shaped graph, just the entire item has been shifted left 3 units. And that would be our graph right there. Now that's our shifts, our translations. Now for reflections. If you have a negative out in front, this is going to reflect, it's going to shift across the x-axis. Now our x squared looks like this. When we shift it, reflect it across the x-axis, it's going to look like this right here. Now it's more than just flipping it upside down, because if you have part of the graph up here, part of the graph down here, you rotate the entire portion. It's kind of like the x-axis is a axle in a car, where it just rotates completely around. Now if I had y is equal to the square root of negative x, instead of the negative being out in front, let's say the negative is inside with the x. Well, this is going to flip, reflect across the y-axis. Now, square root of x, remember, looks like this. So if we flip that, reflect it across the y-axis, it would end up looking like this. So that'd be our graph. Now, those are our reflections. Now, you can have mixtures of these. Let me show you. The idea of these transformations is you can very quickly sketch your graph without picking up a graphing calculator or plotting points. So if I have y is equal to negative x plus 4 squared minus 2, the negative 2 here at the end, that tells us down 2. The plus 4 here, it shifts left to right, opposite what you think. Plus 4 would make me think right 4, so it's going left 4. And this right here reflects across the x-axis. When you have a negative out in front, that reflects across the x-axis. Well, here's our U-shaped graph. Reflect, flip it across the x-axis, it would be flipped upside down and look like this. I then move it left 4 units, it would look like that. And then if I move it down 2, it would look like this right here. So again, the idea is you can very quickly come up with a sketch of the graph without picking up the calculator or plotting points. Now let me clear that off. I see I'm running out of time. So let me just finish that. I want to get down to function composition in section 2.8 because that's a little bit trickier. Notation throws people off. Let's say I have f of x is equal to 3x minus 2, and g of x is equal to 7x plus 1. Now if I'm asked to find this, it looks like fog. It's not. This is not multiplication. It's not fog. This is a composition symbol. This says composition of f and g. Well, we're going to find f of g. Now how this works is f is first here, so f is first here. G is second here, so g is what goes inside the parentheses. I had a student one semester ask, well, I know that's a composition symbol, but couldn't we think of it as O for of? F of g? And that tells you how to set it up. Now, when we're evaluating a function, pretend that g is not here. We're finding f of something. Now what that means is you're going to go to your f of x, which is 3x minus 2, and you replace the x with parentheses. So it looks like this. Now, evaluating is always the same. Whatever's inside this parentheses right here is automatically what you're going to put in here. So put g in there. But g is equal to 7x plus 1. So this becomes 3 times 7x plus 1 minus 2. And 3 times 7 is 21, so that's 21x. 3 times 1 is 3, minus 2, which gives us 21x plus 3 minus 2 is 1. So that gives us 21x plus 1. Now we can find the composition going the other direction too. We can find the composition of g and f, which is g of f. Now here we'd take our g of x, which is 7x plus 1, and where our x is, we put in parentheses. So I got 7 times parentheses plus 1. And evaluating is always the same. So whatever's inside this parentheses is automatically what you're going to put in here. So I'll put an f in there. But f is equal to 3x minus 2. So this becomes 7 times 3x minus 2 plus 1. 7 times 3x is 21x. 7 times negative 2 is negative 14 plus 1. And that gives us 21x. Negative 14 plus 1 is negative 13. And that'd be our composition. Now I'm going to go ahead and stop the video now, and I'll answer any questions you have.